We're looking at the integral of x squared cosine x dx, and we blatantly have a product here in the integrand, and that indicates that we're working with an integration by parts problem. And so what we can do is we can start by letting u equal x squared, and then the derivative of u is 2x, and then we'll let dv equal cosine x, and of course when you integrate cosine x, you're left with sine x. And now, because we're doing integration by parts, we'll go over and then down and across. And so we'll start off with having x squared sine x, and then we'll subtract the integral. We've got a 2 here, so we'll pop that 2 out front, and then we'll say x sine x dx. And now we've got yet another product in the integrand, so we'll have to do another integration by parts. And once again, we'll let u equal x. The derivative of u here is simply the derivative of x. And then we'll do dv equals sine x. And of course, when you integrate sine x, you're left with negative cosine x. And so, yet again, since we're doing integration by parts, we'll go across and then down over. And so we've got x squared sine x minus 2 times, and we're starting with x, times negative cosine x, so that's negative x cosine x minus the integral of minus cosine, which is positive here, cosine x dx. And of course we know that the integral of cosine is just sine x. And so what we're really looking at here is x squared sine x, and then we've got minus 2 times minus x cosine x. That leaves us with plus 2x cosine x, and then we have plus sine x inside of here, but we have a minus 2 out front, so we're doing minus 2 sine x. And because this is an indefinite integral problem, we'll be adding a constant at the end. This entire solution here is the solution to the integral of x squared cosine x. If you've got any questions, or if you'd like me to work on any particular calculus or physics problems, leave them in the comments below. I hope that you found this helpful.